So what we're going to look at here in this video is how to compare a linear function to an exponential function. So one of the best ways we can do this is to do a side-by-side comparison. So if we look at linear functions on the left-hand side and then exponential functions on the right-hand side, we'll be able to see the differences and a few similarities between the two functions. So let's start out with their actual equations. The first thing you'll notice is that in this example, we're using the letter A, but we're more accustomed to using the letter M. So if you want to cross out that A and just change it to an M, that's totally fine. Because what we're used to is we're used to saying M. And remember, our M stands for our slope. So y equals mx plus b. Our M stands for our slope, and our b value stands for our y-intercept. So once we're able to determine your m and your b, those are the main two players when it comes to the linear function. But in an exponential function, we no longer have slope. And the reason why we don't have slope, aka rate of change, is because we're not changing at a constant rate anymore. You're going to see as we jump into these equations that we're changing at different rates. We might start out slow and then get faster, or we might start out fast and then get slower. So in this particular case, we have an a and a b that's all being raised to the x power. That's why these are called exponential, because the x value, the value of x, is actually in the exponent. Hence the word exponential. The word exponent is in there. So let's start out with a. A is going to be what we call our starting amount, or our starting point. Is where we start, or it's the starting amount. You're going to see why we use that word amount for later in the unit. The next thing we talk about is the b value. The b value, in my opinion, is the MVP. It's super, super important because it determines whether our function is growing, so we call that growth, or the opposite of growth is decay. So we often talk about, well, how do things decay? Well, when leaves decay, when they fall off the trees in the fall, things like that. So we'll talk about how things decay, how a function can decay. And then your x value is the exponent. This is now what's your exponent. And when we start to apply this idea to real world scenarios, then your x value is very often going to represent time. So you can kind of put that in quotes here at the end, so you kind of start to realize what's coming. So that's the first component here, is to compare their actual equations to each other. The equations are very different. Notice where x is in the function, right? X is in the exponent versus where x is right here, not in the exponent. So really important that when you look at the function itself, that you see the fundamental differences between a linear function, how it's written, and an exponential function, how it's written. So in the next video, what I want to look at is I want to look at how their rates of change compare to each other. So click next, move into the next video of the playlist.